Hello students, let us solve one more problem from CSRNet 2023 June, and this question ID is 705068, and this is basically from atomic physics. Then the question is given that you have a cadmium atom having two states on D2, on means multiplicity and 2 means total angular momentum quantum number. When there's a transition from on D2 to on P on, you are getting a spectral lines in the absence of any magnetic field, and that line having wavelength 644 nanometer. Okay, this is the case in the absence of any external magnetic field. But in the presence of magnetic field, this line will be split into how many components that they have asked. Okay, so in the presence of weak magnetic field, this line will be split into how many lines that that they have asked. So as you know, this is the we always used to discuss in the class that whenever you have a singlet to singlet transition, it means that that will be your normal Zeeman effect case. Okay, and for singlet to singlet transition, you will always get three Zeeman line. Okay, so each spectral line will be split into three Zeeman line. Okay, so directly for any singlet to singlet transition, that you can blindly follow that rule. But in fact, you can check that also. So suppose you have a on these are the state. Let us denote that energy level of this is E1. With this, it is E2. Okay, and for normal Zeeman effect, this is the case when S equals to 0. This is the S equals to 0 case, and in that case, that part of the Hamiltonian or part of energy can be written as mu b into ml. Okay, and where ml can run from minus L to plus L. Okay, so for this case, basically J equals to L for both states. Okay, it means basically this level will be split into 2J plus 1 or 2L plus 1. That will be 5 components that can be written like this. Okay, and similarly, this will be split into three different lines. Okay, and here that separation between two successive lines or levels, that will be mu bb. For any two successive levels, that separation or splitting will be mu bb. Here also this will be mu bb. And the ml possible ml values, this will be 2, then on, then 0, minus 1, minus 2. Here it will be on, 0, and minus 1. Okay. So as we know that selection rule for transition for this is the case when b is not equals to 0. Selection rule here, that will be delta ml equals to 0, that will be corresponds to pi component, delta ml plus on, that will be corresponds to sigma plus, and delta ml minus on, that is corresponds to sigma minus. Okay, the selection rule that you have to follow. Okay, now if you apply that delta ml 0, so when there is a transition from on to on, that will give you delta ml 0, 0 to 0, that will give you 0, and minus 1 to minus 1. You have a three different transitions are allowed for delta ml 0, delta ml equals to 0. But all three transition will have same energy. It means emitted photon for three transition will have same energy that will contribute a single line. Similarly, if you follow delta ml equals to plus on, it means when there is transition from 2 to on or on to 0 or 0 to minus 1. You have a three different transition are possible. So this is corresponds to ml equals to 0, delta ml equals to 0, and this is corresponds to delta ml equals to plus 1. But again, if you see that energy of these three transition or energy carried out by these three transition will be same. So emitted photon will have same energy. It means they will give you another spectral line. Similarly, delta ML equals to -1. It means when there's a transition from 0 to 1 or -1 to 0 or -2 to -1. Again, these three lines or these three transition will give you same energetic photon. Okay, so this will be your on line, this will correspond to another line, this will correspond to another line. So this delta ML equals to 0, photons have different energy as compared to +1 as compared to -1. So you'll get three different lines. Okay, you can check by using proper selection rule, or directly if you have a singlet to singlet transition, always the spectral line will be split into three different lines. Okay, so the correct answer will be, in the presence of weak magnetic field, this spectral line will be split into three Zeeman line. Okay, thank you.